All right, let's start with section 5.5, and we'll go to 5.6 and 5.5. We're going to look at perfect cubes. Now, notice I didn't say difference of perfect cubes like we had the difference of perfect squares. We can have a plus or a minus sign here. Now, the one thing I want you to understand that a to the third plus b to the third is not three binomials a plus b being multiplied together, or the binomial to the third power. That's absolutely wrong. When we factor this, a plus b to the third power, if you had all three of those and you FOILed this all out, you would get a to the third plus 3a squared b plus 3ab squared plus b squared. You'd have middle terms. Every time you FOIL two binomials or more that look exactly the same, there will be middle terms. All right, so what we're going to do to factor this is we're going to use a four-step technique, which step 1 and step 2 will eventually turn into one step. Now, all perfect cubes are going to factor to a binomial times a trinomial. 2 terms times 3 terms. So when I take a cubed plus b cubed, I'm thinking it's going to be a binomial blank blank and a trinomial 3 blanks. Now, in between my blanks, I got to put in plus and minus signs. So that's where step 2 comes in. And like I said, you'll be able to combine these two together when you see it. Now, what I say is you need to clean up your signs, and to clean anything you have to have soap. Soap is going to stand for something. S is going to stand for the same sign as what you have given. So this binomial sign is always the same sign as the binomial that you're asked to factor. O stands for the opposite sign. The first sign in the trinomial has to be opposite of this binomial. AP stands for always plus at the end. It's always a plus sign here. These two signs are always opposite. So like I said, once you see your a cubed plus b cubed, you can build your binomial and trinomial and put your SOAP in at the same time. So step 3, now what we're going to do is you're going to take the cube root of each term to build the binomial. The cube root of a cubed is a. The cube root of b cubed is b. Binomial is done. Now, once you're done with the binomial, you're going to smile. You're almost done. You're going to go to this binomial and make a smile face. A times a squared. A times b, ab. B times b, b squared. And now it's factored. You are done. That's it. So let's practice some examples here. 27y cubed plus 8x cubed. Power of 3, power of 3. You might check your coefficients here. 27 is a perfect cube. That's 3 cubed. 8 is 2 cubed. All right, so you might want to get your calculator out and identify where the cube root symbol is. So we're going to start this out. I need a binomial with a plus sign and a trinomial opposite, always positive. Plus, minus, plus. Take the cube root of 27y cubed is 3y. Cube root of 8 is 2. Cube root of x is 2x. Now smile for the trinomial. 3y times itself 3y, 9y squared. 3y times 2x, 6xy. 2x times 2x, 4x squared. You're done. It's factored. If we look at 64x cubed, that is 4 to the third power. 125 is 5 to the third power. So binomial, trinomial, our binomial will start with a minus sign. Your trinomial plus plus. Again, first two signs are always opposite. Last sign always plus. Cube root, 4x, not 8x. That's the square root of 64. You got to be careful. 64 is both a perfect square and a perfect cube. Cube root of 125 we said is 5. Now that the binomial is done, we can smile. 4x times 4x is 16x squared. 4x times 5 is 20x. 5 times 5, 25. It's factored. X to the 6, y cubed. If my exponent is a multiple of 3, it's a perfect cube. 216, that's a perfect cube. I believe that's 6 to the 3rd power. So with a minus sign here, we're going to have the same setup as here. Minus plus plus. Take the cube root. That means just take the root and divide it into the power. 6 divided by 3 is 2. 3 divided by 3, 1. So x squared y to the first. Cube root of 216 we said was 6. Time to smile. X squared y times x squared y. X to the 4th y squared. X squared y times 6. 6x squared y. 6 times 6, 36. And we're done. 1000x cubed, 3 zeros, I'm guessing that's 10 cubed. 343, I believe, will be 7 cubed. So plus, minus plus, binomial plus, opposite minus with a plus. Cube root of 1000x cubed is 10x. Cube root is 343, calculator says 7. 10x times 10x, 100x squared. 10x times 7, 70x. 7 times 7, 49. Oh, directions factored completely. We have a GCF here. We're going to take out the a and we're going to take out a 2. So 2a times 8x cubed minus t cubed. Perfect cubed right here. So 2a binomial minus trinomial plus plus. Cube root of 8x cubed, that will be a 2x. Cube root of t cubed is a t. Time to smile. 2x times 2x, 4x squared. 2x times t, 2tx or 2xt. T times t, t squared. And last we have 64x to the 6th minus 1. Highlight this, trick question. Why I say that is because remember we set up here 64 not only is a perfect cube but a perfect square. X to the 6th, multiple of 3, perfect cube, but 6 is even, also a perfect square. 1 is a perfect square and it's a perfect cube. So technically this is both the difference of perfect squares and perfect cubes. So my dilemma here is which one do I do first? Well, let me explain something here. These trinomials that we built, these trinomials are not factorable. We cannot factor these. So I don't want to do perfect cubes and then try to come up with perfect squares if this is not going to factor. So the safest thing to do is the difference of perfect squares first, and perfect cubes are always last. So look for x to the 6th minus 64, putting the 1 here and the 64 there. Watch for x to the 6th with a 64, hit the brakes. So this is going to be a plus and a minus. 8x cubed plus 1, 8x cubed minus 1. The square root of 64 is 8. The square root of x to the 6 is x cubed. Square root of 1 is 1. 1 plus 1 minus. Now, each of these binomials is a perfect cube. So this one is going to be plus, minus, plus. The second one is going to be minus, plus, plus. This factors here, this factors there. Now, the beauty of this is that once you start to build this binomial, you'll be building this binomial because everything will be the same. So when I take the cube root of 8x cubed, this will be a 2x and this will be a 2x because the same cube root of 8x cubed here is the same 2x. Cube root of 1 cube root of 1. 1 can go in both binomials at the same time. Now when we smile, 2x times 2x is going to be 4x squared, but it will also be 4x squared over here. 2x times 1, 2x times 1, 2x and 2x. 1 times 1 will be 1. This 1 times itself will also be a 1. So once you make the outline, once you build this binomial is built at the same time. As you build this trinomial, you'll be building this one at the same time. Now it's completely factored. Now to 5.6, this section is going to be homework that has all your factoring techniques. So what we want to do is kind of come up with an outline of what we want to do in terms of what steps should we take. Well, step 1, you should always check for a GCF first. Again, all your directions here will say factored completely. So find a GCF, then you're going to have your leftovers, if you remember that back in 5.1. Now from here, step 2, 3, and 4 are based on your leftovers. If there are 2 terms in your leftovers, you're going to be checking for the difference of perfect squares and the perfect cubes. All right? So the number of terms in the leftover takes you to the number step. 2 terms left over, you go to step 2, which is 2 terms. Difference of perfect squares first. All right, that's your a squared minus b squared, a plus b, a minus b. Perfect cubes are always second. Okay, remember, soap the signs, and then you make your smiley face. So here, I kind of combine my signs. If it's plus, plus, then a minus. If it's a minus with a plus here. And back here, always plus. Remember, cube root to build the binomial, smile to build your trinomial. All right, now, if I take out the GCF and I have 3 terms left over, then I go to my step 3, where there's 3 terms left over. All right, so here, you got to look at your signs to determine what is my answer going to look like. AX plus blank, AX plus blank. C was positive, this was positive. We do our ABC rule. You're going to find these 2 numbers, D and E, go in your blanks, and then you check your GCFs, and you have your answer. If you take your GCF and you have 4 terms left over, ax cubed plus bx squared plus cx plus d, we said, oh, we're going to cut this in half, take the GCF of the left, the GCF of the right. The 2 binomials have to be the same. They come out to be one binomial. GCF of the left, GCF of the right is your other binomial. All right, this you're going to see probably 95% of the time. Now, within this section, they're going to throw out a trick question at you. This is a special 4-term factorable polynomial. It is a combination of 2 special techniques that we looked at. It's going to be a trinomial squared and a difference of perfect squared built into one. And what you're going to notice is that, oh, here's my trinomial, x squared, x term constant, and then there's a minus y squared. So this one is not split down the middle. This is a 3-to-1 split. Isolate the one variable being squared that doesn't mix with the others. This trinomial here will always factor into a binomial being squared minus this y squared, which is now a difference of perfect squares. And we would factor this to ax plus b minus y, ax plus b plus y. Now, this could turn into a 1-to-3 split. You would just have the y squared first minus ax squared minus 2abx minus b squared. Factor out the negative, and it'd still be the same thing. I have an example of this. You'll see it so don't panic. All right, factor completely. Here we go. 5x to the fourth minus 80. We take out the GCF of 5. There it is. 2 terms left over. We go to step 2. Difference of perfect squares. Okay. X squared plus 4. X squared minus 4. Whoops. Wait a minute. That's another difference of perfect squares. So this breaks down to x plus 2x minus 2, but this doesn't change. It's not a difference, it's a plus. Now we're done. So when you look at this problem, x to the fourth, you're going to try to come up with 4 factors with an x in it. Okay, we can only come up with 3 because of the x squared plus 4. Here we have x to the fourth plus 10x cubed minus 36x squared minus 90x. X's and everything, all even. I'm looking to take out a 2x. There's my GCF. This is what's left over. This 2x goes in my answer. 1, 2, 3, 4 terms, all in descending order. Cut it in half. So we will have a x squared from these 2 terms with a 2x plus 5. 2x plus 5 means we've got to take out a minus 9. 2x plus 5 come together. X squared minus 9 come together. Oh, wait a minute. X squared minus 9, that's a difference of perfect squares hiding in there. So 2x plus 2 times 2x plus 5 times x plus 3 times x minus 3. X to the fourth power. Notice 1x to the 2x to the first, 2x plus 5, an x plus 3, and an x minus 3. Each one has a factor of x in it. X to the fifth, looking to have 5 individual x's. I'm not sure if we can do that, but I can see 3 can come out of everything, so we'll take out a 3. And this again, factor by grouping. Cut it in half. Take out an x cubed, leaves me x squared minus 1, x squared minus 1. Now the reason I put this problem in here is because, oh look, difference of perfect squares. We should factor each one of these. No, you shouldn't. You have not finished factor by grouping yet. So x squared minus 1, x squared minus 1 has to come together as one binomial. Then the x cubed minus 8, oh, there's my, wait a minute, difference of perfect squares, perfect cubes. This is going to factor to 3, x plus 1, x minus 1 from the difference of perfect cubes. And here, or excuse me, difference of perfect squares. And here's my perfect cubes. Minus, plus, plus, cube root of x cubed x, cube root of 8, 2, x times x, x squared, x times 2, 2x, 2 times 2, 4. Now it's all factored. Remember, x to the fifth, x to the 1, x to the 1, that's 2, x to the 1, that's 3, x squared, that's x to the fifth. Oh, here's x to the sixth with a 64 and a minus. Okay, difference of squares and perfect cubes at the same time. Remember, difference of perfect squares first, x cubed plus 8, x cubed minus 8. These are both perfect cubes. Here's your x cubed minus 8, so we're not going to recreate the wheel. We'll just take this answer, one with the plus and then the minus and the plus. We'll just borrow that answer since we've already created it. All right, next example, 7x squared plus 35x plus 42. I see a lot of multiples of 7, so I'm going to factor out the 7. 3 terms left over. What 2 numbers multiply to be 6 and add up to 5? How about a 2 and a 3? That's my 1x squared shortcut. So 7x plus 3 or x plus 2 or x plus 2, x plus 3. Doesn't matter the order of the binomials. 3x to the fourth minus 30x cubed minus 72x. We're going to take out an x squared and a 3. So GCF of 3x squared. We have a trinomial left over. I think we saw this one before. 2 numbers that multiply to be 24 and subtract to be 10. 12 and 2, with the 12 being the minus sign and the 2 being the plus sign. And now we're all factored. And here is my special factor by grouping. 4 terms, x squared plus 6x plus 9, but here's this minus y squared. What's it doing here? isolate it. This is the 3-to-1 split. This trinomial must factor to a binomial squared. X plus 3 squared. Now this is a difference of perfect squares. So x plus 3 with the plus y, x plus 3 with the minus y. You don't have to have the parentheses in this one, but I tell you it's good to put those in there because it's going to help on this one. Here you have y squared, then it's minus x squared minus 6x minus 9. It's technically this problem here with all these terms being multiplied by a negative 1. So that becomes a 1-to-3 split. Now remember, you can drop the parentheses here because nothing's being multiplied into the binomial x plus 3. But it's good to leave those there. I do. It's not wrong if you leave them there. Watch what happens here. You will take these three terms and factor out a negative. There's my x squared plus 6x plus 9, which we know now factors to x plus 3 squared. This is still a difference of perfect squares. Y plus the binomial x plus 3, y minus the binomial x plus 3. Sure, with the plus sign here, I don't need the parentheses, but if I want to drop the parentheses here, I have to distribute the minus sign. And that becomes y minus x minus 3. And the number one mistake, you're probably going to see this on the test, all right, is just leave the parentheses around that and be done with it. So here, done. Here, done. Don't mess with it. A lot of people will just go, oh, y plus x plus 3, y minus x plus 3. No, it's not going to work. Leave the parentheses, you'll be fine. And that wraps up our 5-5 and 5-6.